Good morning, I am Aditi studying in BSc Chemistry Honours second year. Today in this video, we are reading Unit 4 of Inorganic Chemistry, the principles of metallurgy and chemistry of ferrous, copper, nickel, uranium, silver and lead. Metals occurs in nature, sometimes free but mostly in combined state. Those found in free or in native state are copper, mercury, silver, gold, and lead. The metals are found in the combined state with other metals and are combined by mining from the earth are known as minerals. Copper minerals are oxide ores, sulfide minerals are etc. Ore. When a mineral contains sufficient quantity of a metal combined with other elements from which it can be readily separated so as to render the extraction of gold metal of good quality probable, it is said to be an ore of metal. All ores are mineral, but all minerals are not ores. Gangular matrix. The ores usually contains a large number of impurities like earth matters, rock stones, sand, limestones, mica and other silicates. These impurities are known as gangular matrix. The ores are divided into four groups: native ores or free states. The less reactive metals like copper, silver, gold, platinum, mercury, and lead occur in free state. These metals are known as native ores. Oxide ores. These ores are classified as oxides and hydroxides. The metals like copper, zinc, lead, aluminium, tin, chromium, manganese, vanadium, ferrous, titanium, magnesium, beryllium, bismuth, etc. occur as oxide and hydroxides. Carbonates, the metals like Fe, Cu, Zn, Pb, Mn, Ca, Sr, Ba, Mg, etc. occurs carbonate ore. Sulfate, the metals like Sr, Ca, Ba, etc. occurs as sulfate ores. Carbonates, the metals like Fe, Cu, Zn, Pb, Mn, Ca, Sr, Ba, Mg, etc. occur as carbonate ore. Sulfate, the metals like Sr, Ca, Ba, etc. occurs at sulfate ores. Silicate, the metals like Cu, Zn, Ni, Al, Be, etc. occurs as silicate. The metals like Ca, Sr are act as phosphate ores. Sulfide and aranside ores. The metals like Cu, Zn, Fe, Cu, Ni, Pb and Ag, etc. occur as sulfide and aranside ores. Copper pyrites, pitchblende. Halide ores, including chlorides and oxychloride, metals like Na, K, Mg, Ag, etc. are obtained as chlorides and oxychlorides. Na common salt, NaCl. Kernelite, nitrate ores. The metal like Na, K, etc. occurs in form of nitrate ores. Na chili saltpeter. Metallurgy. It is a branch of science dealing with the method of extraction of metals from their ores and preparation of alloys. Generally, few methods are used for isolation or extraction of metals. Ore dressing or concentration of ore. The ore usually contains large quantity of impurities like earthy matter, rock stones, mica, feldspar, etc., which is known as the gangular matrix. Removal of these impurities from ore is called as one ore dressing or construction of ore. During ore dressing, the percent of metal increases, so it is known as concentration. The purified ore is known as concentrate. The operations carried out during one dressing are as follows. Hand picking. The ores can be separated by sufficient degree of purity by simply picking it by hand and breaking the rock stones with hammers. The specific gravity. The ores is crushed in jaw crushers and powdered in bowl mills. If the ore and gangue have different specific gravity, and if the ore is lighter and gangue is heavier, then it is concentrated by gravity separation. In this method, the powdered ore falls on jerky, slopy table and the stream of water is passed. So the ore is flown away with stream of water and impurities fall below table from where it is removed. Magnetic separation. This method is used when ore and gangue having some same specific gravity, but one is magnetic and the other is non-magnetic. Ore is magnetic and gangue is non-magnetic. A thin layer of powdered ore is allowed to fall on a rubber belt which moves horizontally and then passes over a pulley and a magnetic field. Gangue particles or the particles of a lighter and gangue is heavier, then it concentrated by gravity separation. In this method, the powdered ore falls on jerky slopy table and the stream of water is passed. So the ore is flown away with stream of water and impurities fall below table from where it is removed. Magnetic separation. This method is used when ore and gangue having same specific gravity, but one is magnetic and the other is non-magnetic. That is, ore is magnetic and gangue is non-magnetic. A thin layer of powdered ore is allowed to fall on a rubber belt which moves horizontally and then passes over a pulley and a magnetic field. Gangue particles or the particles of a non-magnetic mineral fall off as the belt becomes vertical. The magnetic particles are retained on the belt until they pass out of the influence of the magnet. Magnetic separation. Froth flotation process. This process depends on the fact that certain minerals are wetted by oil while gangue is wetted by water. Mainly this process is used for the concentration of sulfide ore of CuPb, ZnHg etc., copper, lead, zinc, mercury etc. The grounded powdered ore is taken into a big tank. To this a mixture of water and small quantities of turpentine oil or pine oil and suitable additive Na2CO3 is added. Then compressed air is passed so that the whole mixture is agitated violently and froth is produced. The ore particles stick to the oil particles and came out on the surface as foam and it is collected. The impurities like earthy matters, rock stones, limestone, mica, etc. are wetted by water, becomes heavier and settles down at the bottom of the tank. By using this process, the sulfide ores of copper, zinc and lead are separated from impurities. Here the froth formation process. Look at this. Calcination and roasting. For chemical reduction, the concentrated ore is converted into oxide by calcination and roasting. Calcination. It is the process of heating the ore at low temperature in the absence of any blast of air. The moisture, CO2, etc. are removed and the ore becomes porous. That is when limestone is heated, CO2 is given off and it is said to. Roasting. It is a process of heating the ore strongly in excess of air. The roasting includes the following steps. Oxidizing roasting. The volatile impurities like L, LiS, Sb are removed as volatile. It is used for Cu, FeS2, ZnS, etc. Blast roasting. The blast of hot air is passed through the ore for the explosion of sulfur and metal is converted into oxide. This method is used for galena and copper pyrites. Chlorodizing roasting. It means the conversion of a metal of ore into a chloride by heating with common salt in presence of air. Silver is converted to AgCl and then amalgamated for extraction of metal Ag. Sulfating roast. Sulfating roasting. It is a partial oxidizing roasting in which a sulfate is not converted to an oxide but soluble sulfate, that is copper sulfide to copper sulfate. These soluble salts are taken with water and used for further treatment. Calcination and roasting are carried out in laboratory furnace. Sometimes kilns are also used. Smelting. It is a general term used for various operations whereby the metal is separated by fusion from ore. Chemical reduction by using powerful reducing agent for the extraction of rather less electropositive metal. Powerful reducing agents such as H2CO water gas, NaKBAl, Mg and M may be used. Cr and Mn are obtained by reduction of their oxides by AI powder. This method is known as gold. Suchmet aluminothermic process. A mixture of metallic oxide and AI powder is known as thermite, and hence this process is called as thermite process. Carbon reduction process. The oxides of less electropositive metals like Pb, Zn, Cu, Sn, etc. are reduced by heating them with coal or coke. Flux and slag. In order to remove infusible impurities, a suitable substance known as flux is added during reduction process to convert infusible impurities to fusible material, which is known as a slug. The slug is lighter than molten metal, hence it floats over metal and is removed from slag hole. The nature of the flux used depends on nature of impurity to be removed. An acidic flux is used to remove basic impurity. An acidic flux is used to remove basic impurity. A basic flux is used to remove acidic impurity. Acidic impurity. Some ores are self-fluxing because they contain some gangue which is itself fusible and no foreign flux is required. Air reduction. This process is applicable to the extraction of less electropositive metals, may be reduced without using any additional reducing agent. Higher temperature and an ion present with metal bring this change. Cinnabar is roasted in air until a part is converted to oxide. On further heating in the absence of air, the oxide reacts with unchanged HGS to give Hg. This process is called auto-reduction. Electrolytic reduction. When the oxides of highly electropositive metal like alkali metals, alkaline earth metals, Al, etc. are heated with carbon at high temperature, the metal combine with carbon and form carbide. These metals are extracted by electrolysis of their oxides, hydroxides, and chlorides in fused state. Some other salt may be used to lower the melting point of the compounds under electrolysis. The addition of salt helps in electrolysis in following ways. To lower the vapor pressure of metal, it reduces the corrosion troubles, for example in manufacture of Na by electrolysis of fused mixture of NaCl. The addition of the salts helps in electrolysis in following ways. To lower the vapor pressure of metal, it reduces the corrosion troubles. For example, in manufacture of Na by electrolysis of fused mixture of NaCl and CaCl2, the reactions are as under. Refining or purification of metals. The metals obtained after smelting contain greater or lesser amount of impurities. These impure metals are purified by various ways: distillation, liquidation, sublimation, electrolysis. Furnaces. The principal types of furnaces used in metallurgy are as follows: laboratory furnace, blast furnace, open hearth furnace, muffle furnace, electrical furnace, kilns. Refining or purification of metals. The metals obtained after smelting contain greater or lesser amount of impurities. These impure metals are purified by various ways: distillation, liquefaction, sublimation, electrolysis, furnaces. The principal types of furnaces used in metallurgy are as follows: reverberatory furnace, blast furnace, open hearth furnace, muffle furnace, electrical furnace, kilns, reverberatory furnace. Reverberatory furnace. In this furnace, the fuel is burnt in a separate part of the furnace which is known as fireplace. The fireplace is closed at the bottom by iron bars on which the fuel is placed and burned. The rest of the horizontal part is known as hearth or bed. The roof of the furnace is concave and takes bend towards the end away from the fireplace and communicates with the chimney. The charge is placed on the hearth and fuel is burnt on the fireplace. So the hot gases and flames are deflected towards the hearth by the concave roof. Thus the charge is heated and it will not come in direct contact with fuel. Since the fuel does not come in direct contact with charge, the reverberatory furnace that can be used for reduction as well as oxidation process. For reduction, the material is mixed with reducing agent like coke and carbon. While for oxidation, it is heated in a current of air. The calcination and roasting are carried out in this furnace. Blast furnace. It has characteristic shape. It is about 30 meter in height and 6 to 9 meter in diameter. It is made up of steel plates. It is lined inside with fire clay bricks. The hearth may be lined with carbon blocks for durability. On the top of this furnace is cup, cone and hopper system through which charge is introduced in the furnace. Air heated at 550 to 850 Celsius by combination of waste gases is blown under pressure through tires or nozzles. The downcoming charge meets the upward moving hot air blast. The temperature at tires is 1500 Celsius and at top is 200 to 300 Celsius. The product leaves from three places. The molten iron is tapped from the base of the hearth every 6 hours or so. The less dense molten fusible slag floating on the molten iron is tapped more frequently through separate outlet. Waste gases escape through the exit near the top. These gases are purified before combustion. Blast furnace is mainly used for manufacturing of cast iron. Open hearth furnace. These furnace is used for the manufacturing of steel and works on the regenerative principle of heat economy. This furnace is known as Siemens-Martin furnace. The furnace is heated by producer gas burning in the furnace over the hearth. The hot producer gas passes out from the other side of the furnace. In actual practice, the hot gases are made to pass through a brick chamber and then the incoming cold gases are preheated by first passing through this chamber. In this regenerative system, the heat carried away by the fuel gases is not allowed to be waste. The hot flue gases are passed through bricks chamber which get heated and the gases going out of this chamber are at much lower temperature. After some time, fuel gases are passed through this hot chamber and the flue gases are made to heat another brick chamber. The fuel gas is preheated in the chamber, burns and supplies more heat. After some time, the current are again reversed. Refractory material. These are the substances which can bear very high temperature without melting or becoming soft. A suitable refractory material bears following properties. These type of substances do not melt or soften to an appreciable extent upon exposure to intense heat. They resist sudden and great extreme temperatures. They support considerable pressure at high temperature without crumbling. They resist corrosion of slag. Refractory material are used in the form of bricks for the internal lining of the material flues and hotter parts of the chimney. The commonly used refractory materials according to their acidic and basic nature are as follows. Silica in form of gneiss, quartz, sandstones, etc. acidic. Fire clays consisting of 50 to 65% SiO2 and 22 to 35% alumina semi-neutral. Graphite, chromite, bone ash neutral. Lime, dolomite, manganese basic. SiO2 and colonresits temperature up to 1740 degrees Celsius, bauxite bricks up to 1800 Celsius, alumina up to 2000 Celsius, and magnesia and chromite bricks up to 2200 Celsius. Graphite is one of the most valuable material for manufacturing of the furnace. Zirconia ZrO2 is one of the most refractory substance yet known and would up to 2600 Celsius unchanged.